Yes. Yeah. Yeah. Good evening, all. So myself, I'm Vijay. Like I hold 20 plus years of experience in different technologies, right? It's like big data, Hadoop, PySpark, Azure data engineer, right? So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Is my voice clear to all? Is my screen visible to all? Fine. So yeah. So as part of today's course, right, this is what I'm going to discuss. What is big data? Why Hadoop? Drawback with the current databases. Hadoop and Spark advantages, right? Hadoop and Spark job market. That's what I'll be discussing right now. So as part of this course, what I'm going to cover, right? Yes. So big data, Hadoop, PySpark, Python, Core and Advanced will be discussed. Power BI, Linux, MySQL, and also from DURGASOFT side, they're offering Oracle 2 months free training. So this is what I'm going to discuss. Hadoop, PySpark, Python, Power BI, Linux, and MySQL. So this Hadoop, except this Python Core Advanced, it will be from Monday to Friday, any of my 6 a.m. or 9 p.m. batch you can attend, right? Remaining everything is a weekend batch. On the Saturday and Sunday, it will be for 2 hours, right? 2 hours on Saturday, 2 hours on Sunday, these things. Around 16 weekends it goes, right? Yes. Yes. So as part of this course, what I'm going to discuss, just I'll come back to this demo, right? What I'm going to discuss is big data Hadoop, reduction to this Hadoop, HDFS, map reduce means Hadoop components I'll be discussing, scoop for import export operations, yarn, yet another resource negotiator, NoSQL database, different types of NoSQL and one NoSQL database like HBase, and one of the important component of Hive. Hive is for data warehouse purpose, right? We use the language like HQL, which is similar to SQL. One of the important component of Hadoop, right? Hive. Yes. And coming to this PySpark. PySpark in brief, what is Apache Spark, need for PySpark, PySpark already computations, PySpark options, core computations, groupings, aggregations, various inbuilt actions and transformations, PySpark data frame, and various inbuilt functions, PySpark SQL functions, window functions, JSON functions, read-write JSON files, PySpark inbuilt functions, each and every inbuilt functions with working examples. All right, PySpark external sources and deployment modes, local mode, cluster mode, PySpark stages and tasks, drivers and executors, performance tuning, PySpark streaming, integration with Kafka, and PySpark ML. As that you are going to implement using Python, you need to also have knowledge on this Python. So Python basics, operations, operators, IDEs, flow controls, looping statements, strings, collections, list, tuples, sets, dictionaries, functions in Python, modules in Python, packages, file handling, object-oriented programming, regular expressions, database connectivity. So like advanced concepts and like important libraries of Python, introduction to this data science, Pandas model in brief, NumPy model in brief, and Matplotlib. And Power BI, right? So getting data from SQL Server, from SAS, from Excel, from text files, working with transformations, working with visualizations, Power BI filters, and dashboards, working with the sharing work, subscriptions, DAX, and prerequisites, right? Yes, these things I'll be discussing, right? Mainly here, 5 courses will be discussed like Hadoop, PySpark, Python, Power BI, MySQL, right? Database. So coming to this, right? Starting with what is big data? What is big data, right? So if we talk like big data, if you should have seen KBs of data, MBs of data, or GBs or TBs. But today data is getting generated in petabytes, right? Petabytes of data is getting generated. 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit. Okay, prerequisites, everything I am discussing, right? Prerequisites for this, what all the prerequisites, everything is discussed as part of this, nothing. Anyone can update with this. So Python I'm discussing, the prerequisites Python I'm discussing, SQL I'm discussing in this, Linux I'm discussing in this, right? There are no prerequisites, everything you can understand from the basics to the advanced level, right? Yes. We'll get nothing, anyone can update, right? Yes, Rohit. So currently we have got databases like Oracle, MySQL, DB2, SQL Server for OLTP operations, online transactional processing, for online transactional processing. Yes. Yes. So we'll, for the next 1.5 hours, I'll be taking the session for the next 1.5 hours, right? Okay. Oracle, MySQL, DB2, SQL Server. These are the databases. These are the databases, right? They are used for OLTP, online transactional processing. They're used for online transactional processing. Yes. But we have got some specialized databases, Teradata, Netezza, Vertica. They are used for data warehouse, online analytical processing. But these databases, they can handle data up to some extent, but unlimited data storage is not possible. As a solution to all these storage level problems and for processing level problems, a framework, we got a framework was introduced called Hadoop framework. So Hadoop is mainly meant for two things, storage and processing. For storage, HDFS, Hadoop distributed file system. It is not using any database for its storage because databases has got a lot of drawbacks. I'll discuss one by one drawback. Despite of the drawbacks, Hadoop doesn't use any database. It is using a special kind of file system, Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce or Spark. That it is using Spark, Apache Spark. So you may ask, so Hadoop is not for online processing. Hadoop is not it's not for online applications. It is for batch applications. It is for batch processing. So what do you mean by batch processing or what do you mean by batch applications? There are two types of applications. Online applications, batch applications. Online applications, user interactive applications. User gives the input. Booking a movie ticket, you are just going to book it, means you are going to give the input. Making an online money transaction, the source and source account, destination account you are going to provide. We talk about the batch application, user non-interactive. Here, user is nowhere required. User is nowhere required, right? For example, railway ticketing PNR status. Currently, your waiting status is 200. After 2 hours, it is 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Means here user is nothing to do. So here user interference is nowhere required here. Everything happens in the background. So most of the banking applications are financial applications are batch applications. Credit card statements generation, for example, credit card statements generation for millions and trillions of customers. User is nowhere required. Phone bill statement generation. User is nowhere required. So in this way, millions and trillions, right? So where this called as batch applications. And what are the drawbacks with the current databases? What are the drawbacks with the current databases? Why databases can't be used for storing this Hadoop data? Why databases can't be used for storing this Hadoop data? What are the drawbacks with the current databases? We see most of the databases, limited storage. Unlimited data storage is not possible in any of the database. And no parallel processing, no parallel processing. Most of the databases, no parallel processing. And even if you talk about the databases, if volume increasing, the speed is decreasing. Volume increases, speed decreases. To justify this, I'm taking 3 queries here, try to respond for this. Total, I want that select total amount, sum of amount from sales one, which has got 10 records. I want total amount from sales two, which has got 10 lakh records. Select sum of amount, that is total amount from sales 3, another table of 10 crore records. This first table has got 10 records. It has got 10 lakh records. This third table has got 10 crore records. Which query is going to execute faster among these three? Which query executes faster among these three? Obviously, the first query, right? Obviously, the first query is going to be executed faster because 10 records, this one 10 crore, this is 10 lakh. So the first query execute faster as compared with the other ones. So query to query, as the volume increasing, the speed decreasing, right? Query to query, as the volume increasing, speed decreasing. Yes. If complexity increases, even speed decreases, right? If complexity is increasing, speed decreases. Yes. Total amount from sales one, average amount from sales one, standard deviation of amount from sales one. So among these three queries, observe these three queries. Um, so query to query, right? Even here, which query executes faster among this? Which query executes faster among these three? The first query, right? Because total amount, average amount. The second query takes more time because average amount is a two-step process. First sum has to be calculated, next average has to be calculated as compared to the first query. Second query is a time-taking process. And observe this third one, standard deviation, lot of internal processing required. Means as compared to the first and second, third query taking more time, right? Databases can handle only structured data. Major drawback with the databases is they can handle only structured data. They cannot handle unstructured or semi-structured kind of data. For example, if I take an example, just check with this. Yes. If I want to take reviews for a particular movie, I got a table, the reviews table. The name of the table is reviews. Here only two columns, user and the review. User one, user two, user three. In this way, hundreds of users they are giving feedback. User one saying the movie is good. User two saying it is bad. User one good. So in this way, they are giving feedback in the form of ones and zeros. Can you write an SQL query to count the number of ones and zeros? How many people saying it's good? How many people saying not good? Single grouping and single aggregation. Here at select review wise count. Review wise count I want from reviews. Review wise count I want from reviews. Group by review. See, the review wise count I want from that reviews table group by review. So the output review wise means 1 and 0. Count I want review wise 1. 90 people saying it is good, 10 people saying it is bad. 90 people saying it is good, 10 people saying it is bad. Okay, but generally reviews won't be given in the form of ones and zeros. So first person saying that movie is good, they are giving their review in their own text format. Second person saying movie is not good. In this way, they are giving reviews in their own text format. Previously, it was zeros and ones, so it can able to write that query for it. But now, can you write an SQL query now to handle this kind of data? No. Movie is good. Movie is not. So just we can write an SQL query to count the number of goods and not goods, right? Even if we are using this by using a keyword, by using this keyword count good, it gives wrong computation because even not good has got good in it. Yes. So databases cannot handle semi-structured or unstructured data. They can handle only structured data. Hadoop doesn't follow big data Hadoop, right? It won't follow client server architecture. We are not following any request response architecture. We are not developing any web application. It's not for client server or request response architecture. It follows master slave architecture. Single master, multiple slave architecture. Single master and multiple slave architecture. Yes. Hadoop cluster. Group of nodes. Group of nodes means systems. Group of nodes means systems connected in a network. So Hadoop doesn't follow client server. It follows master slave architecture, right? So single master and multiple slaves. Single master and multiple slaves. This we call it as a cluster. Group of nodes connected in a network. Systems connected in a network. In this is the master node. Master node or the driver node we say. These are the slave nodes or worker nodes. S1, S2, S3, so on, Sn. Slave nodes are worker nodes. Hmm. You got a file f1.txt, a big data file. Think that each system capacity 1 TB, 1 TB storage, 1 TB. But f1.txt, the data is 2 TB. This 2 TB file cannot fit into any of the system. Right? It cannot fit into any of the system. So in generally in Hadoop or in Spark, your data is going to be divided into smaller parts. Your data is going to be divided into smaller parts. Each part is going to be stored across multiple systems. So each one is going to get distributed across multiple systems. Means your data is distributed across multiple systems, processed by multiple systems parallelly. That's why you can see very high speed because of parallel processing, and unlimited data storage is possible because of your data is distributed, stored across multiple systems. Yes. Master node responsibility. You check this, right? Master node responsibility is going to assign tasks to the slaves. Master node assigns task assignment to slaves. Balancing the load balancing. Fault tolerance means if multiple slaves are running parallelly, executing multiple tasks, suddenly if any one slave goes down, then the task of it will be assigned to the any of the other slave. That process we call it as fault tolerance. Later I discuss on brief about this fault tolerance. Health monitoring. The master node will have the total health status of each and every, maintains the health status of each and every slave node. Slave node responsibilities, but only two: stores the data and process the data. Generally, if you see the slave node, these are the slaves, they are going to store the data, they are going to process the data. Now coming to this Hadoop advantages. Unlimited data storage, right? Unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited scalability because of a feature, horizontally unlimited scalability. Okay. Yes. Horizontally, unlimited number of slaves can be added. Just check it. If you're running a business, right? If you're running a business with very less number of slaves, if you're running a business with very less number of slaves, assume that, for example, this is the master, multiple slaves. You are running a small business with very less number of slaves. Assume that you are running with 10 slaves, 10 systems. Tomorrow, branches, your customers have increased, your branches have increased, means data has also increased. If customers increased by 100 times, data increased by 1000 times, even you need to increase the number of slaves horizontally. Means horizontally unlimited number of slaves can be added, systems can be added. So if your data is increased, your systems also will be increased. Right. One second, some query was asked. Is there any limit on the number of slaves that a master node can manage? Is there any limit on the number of slaves that a master node? See, yes, I'm coming to it. So single master, multiple slaves, right? So any number of slaves, I mean to say that any number of slaves you can have, any number of slaves you can, unlimited number of slaves. Unlimited number of slaves you can have, single master and multiple slaves, any number of slaves, hundreds and thousands, right? Slaves you can have. That is what unlimited data storage is possible. Unlimited data storage is possible. Very high speed processing, very high speed processing because of parallel processing. Very high speed processing because of parallel processing. Can handle all varieties of data. Can handle all varieties of data. Very high speed processing because of parallel processing, right? Means if hundreds of systems, the data is distributed across hundreds of systems and hundreds of systems running parallelly because we get very high speed. Can handle all varieties of data, structured, semi-structured, and unstructured data. Hadoop can handle all varieties of data. It is an open source, no licensing required. So here, most of these Hadoop products, most of these Hadoop are from Apache website. You can take it, you can download and install it, right? Commodity hardware. Commodity hardware means what? Doesn't mean that you need to have highly configured systems. Doesn't mean that you need to have highly configured systems. It can run on any systems, right? So unlimited data storage, very high speed processing, can handle all varieties of data. Is an open source, no licensing required. Commodity hardware.
So vertical scaling is not possible.
Vertical scaling, you won't get that much of scalability.
So we
Horizontal,
can put a one more master and slave like multiple.
horizontal scaling only, it's possible. Horizontal scaling only, you can get highly scalable. Horizontally, you can keep on, horizontally, you can keep on adding.
Oh,
So this is what I said, right? Horizontally. These are S1, S2, S3, S4, S10, S20, S100, 50,000. In this way, keeps on going. We say commissioning and decommissioning. Commissioning means adding the slaves, decommissioning, removing the slaves. So yes, Hadoop is proven in the market, storage point of view and processing point of view. If you can check, Yahoo has conducted a test to check the speed of different databases, right? It has taken a table of 100 TB consisting of 1024 columns. Task was sorting based on 16 columns. So what is the time taken by the different databases to handle this, right? Oracle has taken around 3.5 days to process this. MySQL has taken around 6 days. Teradata has taken 4.5 hours. Teradata is a specialized database used for data warehouse. That's just taken 4.5 hours. Netija, another specialized database used for data warehouse, it has just taken 3 hours time. Finally, Hadoop has just taken 3.4 minutes. Hadoop has taken just 3.4 minutes. That is what the speed of Hadoop has compared with the other things. These have taken days, these have taken hours of time, these have taken just minutes of time. But as compared to Hadoop, Spark is there. Spark is 100 times faster than Hadoop. See, already Hadoop has got very high speed, but still Spark is 100 times faster than Hadoop. That's the reason today Spark has got high demand in the market. So it's widely used today, means at a very high rate of speed it can process data, that huge data at a both Hadoop and Spark commonly used today, means some components of Hadoop and Spark both commonly used for this processing. And you may ask why databases like Oracle cannot support unlimited storage. Why databases like Oracle won't support unlimited, even in the real time, even databases like Oracle, they can go with multiple slave systems. But there is a limit databases and see the max limit on the number of slave nodes they should have. Oracle can manage up to 256 nodes, 256 slave nodes only. More beyond that, it cannot support. Just like if you take the example of a mobile phone. See, for example, 64 GB internal storage is given. If you fill all the 64 GB internal storage, what happens? The performance of the phone degrades, right? Sometimes it won't even start. Similarly, if 256 nodes are given, if all the nodes gets filled, then this performance of the Oracle will degrade. Performance of the Oracle also will be degraded, right? Yes. So Oracle maximum with 256 nodes, MySQL 54 nodes, MySQL Express it can go with 256 nodes, SQL Server with the 256 nodes. All these databases supporting 256, even DB2. But we have got some specialized databases like Teradata going with 512 nodes. Netija, it is also a specialized database with 512. Vertica also with 512. But this Teradata Netija, they are supporting 1024 systems nodes for storing the data. But none of these databases are specialized databases. They can handle unlimited data. Unlimited data storage is not possible, but there is no limit on the number of slaves that Hadoop can have. Unlimited number of slaves, horizontally unlimited scalability. Yahoo when first time implemented Hadoop, right, went with 4,000 nodes for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. Facebook, when first time implemented Hadoop, went with 8,000 nodes for storing data. Currently, Facebook going with 54,000 nodes for storing its data. So Hadoop is proven in the market, storage point of view with unlimited data storage and processing point of view also, right? Yes. See, storage capacity of a slave node. Slave node is a system. Anything, we cannot say we can have the fixed storage capacity. 1 TB storage, 2 TB storage, anything you can have. See, that's what I said. Hadoop has got commodity hardware. It doesn't mean that you need to have highly configured in order to all the slave systems need to be have same configuration. No. For example, I added 20 systems. After 2 months, again I added 30 more systems of different high configuration. They might be having different configurations and different storage capacities, right? Anything. Yes. So Hadoop has prevent processing point of view with a very high rate of speed. So minutes of time it can process data where they have taken days and hours, but even storage point of view with unlimited data storage, with unlimited there is no limit on the number of slaves that it can have, right? It can go with any number of slaves. Yes. So here, yes, even I said Spark is 100 times faster than Hadoop. Spark is 100 times faster, right? Even Spark. So Spark, so just generally Spark, it is also Spark means here in our course we are will be discussing about PySpark, Spark with Python implementation, right? It is mostly used today, Spark with Python implementation, right? PySpark we say. It is also an open source distributed cluster computing framework. It is also given by Apache Software Foundation. It is a general engine for big data analysis, for processing, and for computation. And what is the need for PySpark? So if it is PySpark, you can say it's a Python API for using Spark. It is PySpark is one of the lightning fast technology that is designed for fast computation. It is a very demanding tool among data engineers. To work with the big data sets. PySpark is used for running distributed SQL. It is used for running distributed SQL, for creating data pipelines, for running ML algorithms, for graph algorithms, for data streaming. And if you see need for PySpark means today large amount of data is getting generated. So the data will contain hidden patterns, market trends, customer preferences, unknown corrections. It is necessary to extract a useful information from that raw data. So we require some efficient tool for performing these kind of operations on this huge data. So, so we require some scalable and flexible tools to crack this big data and gaining benefit from it. So PySpark is one such kind. So combining Python plus Spark is one of the very efficient way for the world of this big data, right? So that's why Apache Spark community, they came up with a tool called PySpark, Python API for using Spark. So it is used in the commercial sector. If you see PySpark is used in the commercial sector for real-time processing. Bank and other financial systems, they are using Spark for retrieving customer social media profile. And they are using Spark to retrieve customer social, okay. And also for credit risk assessments for healthcare and predicting which patient is going to face that issue. And for entertainment industry, like the popular OTT, like Netflix using this Apache Spark for this real-time processing 450 billion events per day. And even trade and e-commerce like Flipkart, Amazon, all this they are using Spark for this advertising. And even the tourism industry in comparing millions of tourism websites and advising the millions of travelers. In this way, many other use cases, right? Yes. So later we discuss about this, right? Yes. So just I'll give some knowledge on this, how exactly the data stored and processed, right? Yes, in Hadoop. How exactly data stored and processed. Yes. Okay. Uh, in Hadoop, data is stored in Hadoop. Data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file is again subdivided. Each file is again subdivided. Each file is again subdivided into blocks. Default block size. Default block size. Each file is again subdivided into block. What will be the default block size? Default block size 64 MB. In latest versions, 128 MB. See, Ashish, right? It's not the name. See, 1 second. In Hadoop, there is a component called Hive that is used for data warehouse kind of operations. Data warehouse kind of operations. Similar to Hive, there is Impala. Hadoop name is not Hive. In Hadoop, there is one component called Hive that is used for data warehouse, or even Impala also performs the same thing. Hive or Impala, they're used for data warehouse kind of operations, right? In the case of, okay, yes, for both used for data warehouse. It's one of the component, yes, one of the component of Hadoop. In, yes, Ashish, right? In Hadoop, Hive is one of the component, but not the another name for Hadoop. It's not Hive. Lot of
Okay,
jobs.
sir.
So if you see, even if in the Hadoop, you just check in the Google, right? Yes, just open Google and just check. Lot of jobs for, even if you have got knowledge on this particular Hadoop component Hive, just check Hive jobs. Just check it, Hive jobs. 14,000 Hive job vacancies in April. Only if you have got knowledge on Hive, right? Thousands of jobs in Hive. That is in Hadoop, one of the component of Hadoop, right? Yes. How exactly data is stored means in the form of file. File is again subdivided into blocks. Default blocks is 128 MB. For example, I got f1.txt, a file 1.txt. Assume this file size is 200 MB. Size equal to 200 MB. I'm taking a small file, right? Into, okay. Assume default block size. Default block size equal to 64 MB. Assume default block size is 64 MB. Even we can set our own block size also. Assume default block size. Into how many blocks this file is divided? Into how many blocks this file is divided? Hmm. File size by default block size. Yeah, you're Rohit, right? Yes. Just I'm going to discuss about those only with multiple examples now. If you have two files whose size is less than 64 128 MB, will they be still be allocated different blocks? Yes. Two files data can't be stored in a single block. Two files data cannot be stored in a single block. No. That's what I'm saying. Now take this file f1.txt. So think that it is some banking data. It has got some banking data in this. File size 200 by 64. 200 by 64. How much?
324.
3 point something you get, right? So approximately take it as 4. Approximately take it as 4 blocks. I want the sessions to be interactive. Everyone try to respond. And if you've got any queries, immediately you can unmute, you can ask. Otherwise, you can ask through chat. All the sessions are interactive sessions. In the practicals, if you want to do, you can do parallel along with me, right? Yes. 4 blocks. 4 blocks means here, think that B1 block, B2 block, B3 block, B4 block. Okay, 4 blocks. Here, B1. 64 MB, B2 also 64 MB, means each fixed size blocks. B3 also 64 MB. But okay, 64, 64, 64, 180, 192. B4 has got only 8 MB, 56 MB free. 56 MB free in this. See where these blocks are stored. See, in Hadoop, your file is divided into multiple blocks, partitions. Each block will be stored across one system. System 1 and system 2. B3 in S3, B4 in S4. So here, divided into 4 blocks distributed across 4 systems and are executed parallelly by 4 systems. This is fine. Now, if I'm taking one more file, f2.txt, now try to respond f2.txt. Assume the size is 192 MB exactly. I'm taking a smaller files to just explain for explaining purpose to show you the blocks and this thing. So here size equal to 192 MB. You've got some telecom data. So just f2.txt, some telecom data in that. Okay. Default blocks as number of blocks means 192 by 64. 192 by 64 means exactly how many blocks? 64, 64, 64. Exactly 192. Exactly 3 blocks, right? Exactly it will be 3 blocks. Three blocks means, for example, B5, B5, B6, B7, and B5 64 MB, 64 MB, in B6 64 MB, in B7 also 64 MB. So here in B5, S5, in B6, S6, in B7, S7, right? So here, okay, you may get one query, right? Here, why B5 data is not stored in B4 when 56 MB is free here? When 56 MB is free here, why B5 data is not stored in B4? Why B5 data is not stored in B4? Why B5 data is not stored in B4 when 56 MB is free? Why B5 data is not stored in B4 when 56 MB is free? Okay.
So to prevent the ambiguity problem.
So here again, already it kept 56 MB free. Again, it went with a new block. The row. Okay. So for example, to make you understand why it is not using it, because retrieving, for example, retrieving which one? F1.txt. Retrieving F1.txt means what? How many blocks F1 has got? I want to retrieve F1.txt. It has got how many blocks? 4 blocks. 4 blocks you need to combine. 4 blocks you need to combine. For example, if B5 data stored, assume for just B5, if B5 data stored in B4, assume if it is stored, what is that? What is that you get? B1 64 MB, B2 also 64 MB, B3 also 64, right? B5 also 8 plus 56. 8 plus 56 MB of totally you are getting 256 MB. But actual file size, but actual file size, hmm, 256 MB. But actual file size is 200 MB. But actual file size is 200 MB. Means you got 56 MB of Telegram. Means while retrieving the banking data, yes, understood, right? Yes. So here, if B5 data stored in B4, what happens is if I am retrieving file1.txt, you are getting a part of file2 data also, which is a wrong computation. That's why every file will have its own dedicated number of blocks. Every file will have its own dedicated number of blocks. Okay, 1 second. Here I'm writing it.
Sir, are we going to see this all the thing practically as well, right?
Yes, yes.
Okay.
Only for this first 3-4 sessions, you'll be having something like theory, but later everything will be practical oriented.
Okay.
Means you need to know something about these things, right? How the data is stored. in what way it is stored, how it is divided, how it is distributed, how it is processed, what is the fault tolerance if any system goes down, what happens, how it is managed, if there is any data loss, then how it is going to overcome. These things will be discussing for the initial session. After that, once we enter into practicals, we won't see any theory there. So design principles with respect to HDFS blocks. Design principles with respect to HDFS blocks. Every file will have, just check this, every file dedicated number of blocks. Every file will have dedicated number of blocks. In a single block, just now someone asked, right? Yes, in a single block, no two files data. In a single block, no two files data to be stored. In a single block, you cannot store, even though, for example, your file size is too small, even if 56 MB is free, even two files, if it can fit into a single block, you cannot store in a single block. Tomorrow, what happens if I'm retrieving, right, that particular block, both the files data you are going to get. Single block, no two files data to be stored. And one more, every block has got equal volume. Every block has got equal volume except the last block. Every block has got equal volume except the last block. See, the last block only will have that. Remaining all will have equal volumes except the last block. We can also configure, increase or decrease the block size. Means if file is divided into fixed size, right? Blocks, we have call it 64, but even into we can have 128 MB. Configuring block size. Configuring block size. Block size means increasing or decreasing. Increasing or decreasing, right? We can also configure, right? We can have our own block size. For that, go to Hadoop install, go to Hadoop install directory. Go to Hadoop install directory. Hadoop etc /conf / hdfs-site.xml. Open, this will be an empty file. This will be an empty file. Open this hdfs- open this configure the following. See, configuration. So like how this XML tags will be there. Configuration / opening and closing / configuration. Within that property slash property. Property, yes. Name slash name. Name and slash name. Name will be right. For example, uh, DFS dot block dot size. This is the name of the property. A value for it. Value for example, it's 128 MB. If you want to set like 70 MB or 80 MB or 90 MB, 90 M you can say. 90 MB means value. Or 50 MB you want, how much you want to keep, you can just keep it. Yeah, recording of the session will be getting to your mail ID, right? With whatever mail ID, you will be getting a link, a YouTube link. But this first two, 3 sessions will be kept in the YouTube, right? You will be getting to your mail ID. You can check there. A link you will be getting. You can just record with that recording. Yes. Okay, and configure the following configuration and slash configuration. Just check this. This is what I need to write. This very small, right? Configuration, closing tag, property and slash property, name and slash name, value and slash value.
So this
So,
file is available on which server?
so yes. So wherever your Hadoop is installed, right? In the Hadoop installed folder, there will be one more folder, etc subdirectory. Within that within the conf, this subfolder, you will see a file in that. Whenever Hadoop is installed, you will see a folder with the name Hadoop. In that folder, if you go and check, you will be seeing a file hdfs-site.xml. It's an empty file. If it is an empty file, if nothing is configured, by default, it takes 128 MB as the default block size. Previously, it was 64. Now it is taking, in the latest versions, it is taking 128 MB. So if you want to keep your own block size, then you need to write this code, configure.
Sir, why Facebook is still using the Hadoop if we have the PySpark and all the thing?
PySpark is for processing. See, one thing, PySpark is Hadoop performs two things. Hadoop performs both storage and processing. PySpark is only for processing.
Oh,
PySpark is a
okay.
processing execution. It cannot store, but Hadoop can both stores unlimited data and unlimited data processing. Both it can do. And the two for Spark, the companies which prefer Spark need to have a lot of, they need to spend a lot of infrastructure. They need to afford a lot of infrastructure because huge RAM capacity, because Spark data will be stored in the RAM, the in memory computation. We say Spark is got why that much speed, because in memory computation, everything storage happens in the memory level, in the RAM level, not in the disk level. So if you are able to afford big RAMs, you can afford, then you can go with Spark, right? Otherwise, Hadoop is used. Today, even Hadoop is used, mostly used, like even Hive is used a lot, Scoop is used, many other components of Hadoop, that whatever they are used, I'll be discussing as part of this course.
So,
There were many components of Hadoop that outdated components I'm not going to discuss, but which are
so
mostly
actually,
used.
people are saying like Hadoop is going to remove like the job and all the thing. So,
See, see one thing, Spark runs on Hadoop cluster only.
oh,
Spark doesn't have any cluster. Spark has to run on the Hadoop yarn cluster only. So
okay.
most of this, see, Hadoop is a kind of a revolution. It is a revolution. It brought a big revolution in this distributed computing, right? Yes. Previously, only a single computer, but when Hadoop came into that, right, the distributed computing was introduced, right? it became a revolution in that industry, right? When Hadoop introducing that distributed computing systems, where data is distributed by multiples, just like very simple. If you take a labor example, if you take a labor example, a building construction, if you take a single labor is constructing that building, right, takes months and months of time. But if you have got some 20 labors, 30 labors working parallelly, it is going to complete, the job is going to be complete faster. Means you are that whatever the building construction job is divided into tasks, job is going to be divided into tasks, multiple tasks given to multiple labors, they will be executed parallelly they will be running it. The same way in Hadoop also, your data is distributed across multiple systems running parallelly, executing that because of this parallel processing, where it can perform both storage and processing. So as a majority of our discussion will be in PySpark only, because PySpark means Hadoop components which are required, right? That I'll be discussing, like HDFS is required, file system, like Scoop is required, Apache Hive. It's still, I just now I showed you, right? Lot of jobs on Hive. Hive query language is there, right? Hive is one of the and even in Hadoop combination of with NoSQL database, NoSQL, not only SQL. These things, yeah, both with means if you go to that interview, right? They along with Spark, they'll ask if you got knowledge on Hadoop or not. Basics of at least basics of Hadoop, right? So majority, if we take 70%, 65 to 70% discussion on PySpark, remaining 30% on this Hadoop, which are required, which knowledge is required for that understanding PySpark. Hadoop distributed file system is there. Means PySpark taking input from that HDFS file system and writes the data back to this HDFS file system. Hadoop distributed file system, right? PySpark is a processing component, a processing execution model, right? It's going to process the data. Okay. So here, keeping, okay, default block size. You can keep your own block size. Try to respond, which is advantageous. Which is advantageous.
Sir, if we decrease the volume, then we need the number of block more, right? So we can keep the default size only.
Which is advantageous, having bigger default block size or smaller. Example one, you see. Example one, you check and try to comment on this.
So smaller will be beneficial because if we'll have bigger, then it will lead to wastage of the storage space.
Okay. Yes. You mean to say bigger default block size will be, or smaller will be the advantages you are saying.
Yes.
Okay. You need to understand why Hadoop has given 128 MB as default. Why Hadoop has given 128 MB? It's still using the developers to take your own block size also. So here, example one, check this. f1.txt. File size equal to size of the file equal to 900 MB, 900 MB the file size. Default block size I'm setting to, for example, 500 MB I'm keeping. By default block size 128 MB as Hadoop has given, but it is saying you can also keep your own block size. If I'm keeping 500 MB, is it advantageous or disadvantageous? How many blocks you will get? How many blocks?
2 block.
900 by 500. Approximately 2 blocks. 2 blocks. B1, B2. B1 of 500 MB, B2 of 400 MB. It's stored in system one. So you don't need to worry about all this taken by the Hadoop framework. You don't need to store these things. It's totally the responsibility of the Hadoop framework to store all this dividing into blocks. Just you need to give the default blocks as that's it. It is going to divide into blocks and stores across multiple systems. Yes, S1, B1 in S1, B2 in S2. Assume you have 40 node cluster. Assume you had 40 node cluster. But only 2 nodes are running. If you have distributed across,
By two nodes, do you mean one master, one slave, or two slaves?
it is generally data will be stored in the slaves only. S1, slave 1, slave 2. Master will be there. Master will be separate, but always data will be stored within the slaves. Data is processed by the slaves. Here, two slaves, S1, S2. But only 2 nodes are running parallelly. Less speed, right? Less speed means, for example, you brought 40 laborers for building construction, but you are using only 2 laborers, but 38 laborers are sitting ideally. If the same data, if the same work, if you have distributed at least to 20 to 30 workers, more speed you should have achieved. The same data, if you have distributed to multiple systems, here I've taken, okay, a small data volume, but if you have got a bigger file, right, if you need to distribute it, if only 2 systems are running parallelly, less speed. The same thing, if you have given to 20 systems, you should have got achieve more speed. If 20 labors for the building construction, you should have got more speed than the 2 labors, right? Even though you have got those many cluster known systems available, less speed. Data is distributed across only 2 systems and data is processed only by 2 systems, less speed. Take example 2 now. Just example 2 you take. In the case of example 2, f2.txt is there. I got a file f2.txt. The file size is 60 MB. Size equal to 60 MB. Default blocks I am taking very small size. 5 MB I am taking. Number of blocks, how many?
9.
60 by 5.
12.
Stored across 12 systems and are processed parallelly. Stored across 12 systems and are processed parallelly, right? Is it advantages or drawback? Is it advantages or is it a drawback? 12 blocks stored across 12 systems and are processed parallelly. You will get high
Sir,
speed.
the speed will be high, processing will be high, but as compared to the example one, but the resource utilization will be high as compared to one.
See, okay, yes, exactly. So here, already, see here, already is a very small file. Already it is a very small file. And again, already it is a very small file. Again, dividing it into smaller parts, again distributing across multiple nodes, and again collecting the result from multiple nodes, the time-taking process. Small file, you are dividing into very, very smaller parts, again storing into multiple systems, and again you are collecting the result from these multiple systems, the time-taking process. So that's the reason Hadoop is giving default block size as 128 MB, which is not too big or which is not too small. So the default block size should not be too big or too small. So that's the reason Hadoop is giving default block size as 128 MB. 128 MB blocks we are going to get. Yes. How exactly data stored and processed in Hadoop? How exactly data stored and processed in Hadoop? Right? Just I'm going to discuss 3 cases, try to understand clearly how exactly data stored and processed in Hadoop. Observe this case one. The number of blocks, we got some file is divided into number of blocks, right? If the number of blocks, if it is greater than the number of slave systems, otherwise number of blocks, if it is equal to number of slaves, assume that if the number of blocks is equal to number of very high speed, you achieve very high speed. If the number of blocks, if it is equal to number of slaves, assume that you have got 4 blocks, 4 slaves. 4 blocks means you have got B1 block, B2 block, B3 block, B4 block. How many slaves? S1, S2, S3, S4, 4 slaves. So here if we got f1.txt, file1.txt, assume that 230 MB is the size. Assume that default block size for this example purpose, default block size, okay, 64 MB I am taking default block size. Into how many blocks it is divided? Number of blocks, 230 by 64 means how many? 230 by 64, how many? 4 blocks. 4 blocks. 4 blocks means B1, B2, B3, B4. And think that in B1 10 lakh records, in B2 10 lakh records, in B3 10 lakh records, in B4 10 lakh records are stored, assume. Okay, here this is your master. This is your master. And how many slaves? Think you got 4 slaves. 1, 2, 3, 4. B1, 4 systems are there. slave 1, slave 2, slave 3, slave 4. Here B1 is stored, which has got 10 lakh records, B2, B3, B4, 4 records. This is your master. These are your slaves. Slaves will store your data, and slaves are going to process your data. They are going to process your data. So within the master node, you are going to see name node. Name node maintains metadata information. Metadata means data about data. Metadata. Data about data. Data about data, right? Yes. Here I got f1.txt. F1.txt, it is divided into 4 blocks. B1, B2, B3 and B4. B1, B2, B3, B4. B1 stored in S1, B2 stored in S2, B3 in S3, B4 in S4. So totally this name node is storing this metadata, data about data. These 4 blocks stored across 4 slaves. And this data, total information will be maintained by the master node, that is name node, we say, this entire information. But in the slaves, data is stored, data is processed. This is how exactly data is stored within this. Your blocks are getting distributed across multiple slaves. That is data storage. We talk about data processing. Talk about the data processing here, right? Job is to process f1.txt file. Huge file, a bigger data file. Always in Hadoop, the job will be divided into tasks. Job will be divided into tasks. Number of tasks equal to number of unique blocks. Understand, I am using the word unique. Number of unique blocks. How many unique blocks here? 4 blocks. 4 blocks means how many tasks? 4 tasks. Number of unique blocks are 4. Means tasks also 4. Means try to understand, you are trying to execute, you are trying to process f1.txt. This divided into 4 tasks. How many tasks? T1, T2, T3, T4. T1 task. T1 task for what? For executing what? B1. B1 10 lakh records. T2 task is for executing B2. T3 task is for executing B3. T3 task, T4 task is for executing B4. Now try to respond. Who should execute this T1 task? Who should execute this T1 task? Which system has to execute this T1 task? T1 task is nothing but executing B1. Who should execute this B1? Which system? Which slave system has to execute this B1? S1 only. Everyone, try to respond. S1 only, right? Because T1 task is for executing B1. B1 is stored in system 1. System 1 only has to execute or process that. Similarly, T2 task, S2 only should execute. T3, S3 only. There is no other choice. T4 by S4 only. Means here, what is your observation? Here, 4 tasks. Here, 4 tasks. T1, T2, T3, T4. 4 tasks are executed. 4 tasks are executed by 4 slaves. 4 slaves. S1, S2, S3, S4. Parallelly. 4 tasks are executed by 4 slaves parallelly. No, none of the task is in the waiting state. All the 4 tasks by 4 slaves parallelly. That's why high speed you can see. That's why you're able to see high speed. So if the job is divided into tasks only, then they can be executed parallelly and you can see the high speed. Just like in the building construction also, a job, if you divide into tasks and if you distribute it across multiple labors, they will be working parallelly. You can achieve high speed. But if you observe the same thing, if you observe in case 2, you see less speed. When you see less speed, observe case 2. And this again, you can observe how the storage and processing is happening in the big data Hadoop. Assume the number of blocks, whatever it is. If it is number of blocks greater than number of slaves, assume that you have got 4 blocks, but you have got only 2 slaves. Blocks are like B1, B2, B3, and B4. Slaves how many? S1, S2 only. 2 slaves only. See, assume that f1.txt size equal to 230 MB. Default block size 64 MB, assume. Into how many blocks? 230 by 64. How many blocks? 4 blocks. How many blocks? 4 blocks. 4 blocks means, okay, B1, B2, B3, B4. Okay, that's just like previous example. You got 4 blocks. But the 4 blocks, this is your master, but only 2 slaves only available. The number of systems, slave systems are less. So here, this is S1, this is S2, this is S1, this is S2. In S1, see, 4 blocks need to be distributed across 2 systems. So B1 here, B2 here. Again, B3 here, B4 here. Means the blocks are getting distributed across multiple systems. If 10 blocks are there, only to 5 blocks in the first system, 5 blocks in the second system. If we have got 10 blocks. So here, this is the master node. This is the master node. Within that, we will have got a name node. Name node will maintain metadata. Metadata means data about data. So for example, data about f1.txt divided into 4 blocks, B1, B2, B3, B4. B1 stored by S1, B2 by S2. Again, B3 by S1, B4 by S2. In this way, how the blocks and how the slaves are stored, right? Blocks and slaves, this kind of information stored by this master node. Within that, we have got name node. Only the metadata information will be available in the master. In the slaves, actual data is stored and the actual data is processed. This is how the data is stored. How data is stored. Now, data processing. If you observe this data processing, you have got any queries, you can unmute and you can ask me, right? Yes, or you can type in the chat. So, data processing, your job is to process f1.txt. Job always divides into tasks. Number of tasks. How many tasks? Number of unique blocks. Number of unique blocks. How many unique blocks? How many unique blocks? 4 blocks. 4 blocks means 4 tasks. 4 tasks. Now try to observe here. Your job is to process f1.txt divided into how many tasks? T1, T2, T3, T4. So don't worry, clear notes is available for all these things. I'll forward you these notes. T1. T1 is for executing what? B1. T1 is for executing this B1 block. T2 is for executing B2 block. Task 3 is for executing B3 block. Task 4 is executing B4. Who should execute this T1 task? Which system? Everyone, unmute yourself and try to respond. I want the sessions to be more interactive. T1, executing B1. B1 is present in system 1. Who should execute? S1. T2 task 2. That is for executing B2. Who should execute it? T3 task B3. Again, it is S1. S1 only should execute. Again, T4 task. That is for block 4. S2 should execute. Here, if you observe carefully, you got system 1, system 2, 2 slaves. S1 executing how many tasks? T1 and T3. S2 is executing how many? T2 and T4. When T1 is executing, what about T3 then? T3 will be in the waiting state. T3 will be in the waiting state. When T2 is executing here in this system 2, T4 will be in the waiting state. Very simple logic, right? If you have got 4 tasks, but only 2 labors are available. First two tasks to that one labor, again 2 tasks to that, but they can execute only one task. After completing the first task, they will execute the second task. Means here, these tasks are in the waiting state, right? T3 and T4 are in the waiting. T1 and T2 only are executing parallel. In the previous example, 4 tasks, all T1, T2, T3, T4 were executed parallelly. But here, only 2 are executing. Remaining 2 are in the waiting state. Remaining 2 are in the waiting state. Right? 2 are executed parallelly. 2 are in the waiting state. Means if they are in the waiting state, if you talk, each task takes 1 hour. In first hour, only 2 tasks executes parallel. Again, in second hour, again 2 tasks, means 2 hours it takes. But in the previous case, all the 4 tasks parallelly within 1 hour, everything executes. So here, some tasks are in the waiting state. So that's why you will be in the less speed. Yes. More slaves, more speed. Less slaves, less speed. But if you see that case 3, no parallel processing at all. Here, at least you are going to see some parallel process among T1 and T2 are executed parallelly. But T3, T4, they are in the wait. But in the case 3, there won't be any parallel processing at all. Sequentially, you are going to process one task after the other. More blocks, one slave. Think that you got 4 blocks, only one slave S1, B1, B2, B3, B4, only one slave S1. Okay. F1.txt, right? F1.txt. Yes. You got 230 MB. Default block size 64 MB. Into how many blocks? Number of blocks 230 by 64. You are going to see 4 blocks. 4 blocks means B1, B2, B3, and B4. How these 4 blocks are stored across? Here only one slave, I said, only one slave. All this B1, B2, B3, B4, everything is stored here itself. This is master. Within the master node, we see name node. It is a system service. So it stores metadata information, data about data. So here f1.txt stores divided into 4 blocks, B1, B2, B3, B4. Where B1 stored in S1 only, B2 in S1, B3 in S1, B4 in S1. All stored in S1 only. Now, if you come to this data processing, that is data stored in a single system, data processing, job to process f1.txt, f1.txt into how many blocks, into how many tasks, number of tasks equal to number of unique blocks, number of unique blocks. How many unique blocks? How many are there? 4 are there, right? So how many tasks? 4 tasks. 4 tasks. Okay. These 4 tasks like T1, T2, T3, T4. T1, T2, T3, T4. Who should execute this T1? S1 only, T2, S1 only, T3, S1 only, T4, S1 only. So this S1 only should execute all the here 4 tasks. Here 4 tasks. Should be executed by single, should be executed by single slave. Here 4 tasks T1, T3 should be executed by S1 only sequentially. Here 4 tasks should be executed by S1 only sequentially. One after the other, right? If each task takes 1 hour, total time taken is 4 hours to execute. In the case 1, it will take 1 hour. All 4 tasks at a time in a single hour, they are going to execute parallelly. In case 2, it takes 2 hours. First hour, like 2 tasks will be executed parallelly. Next hour, again 2 tasks will be executed. Here, yes, understood. More slaves, more speed. Less slaves, less speed. If only one slave, right? No parallel processing at all. Here, any queries in these 3 cases?
Sir, cluster, who will decide?
What is it?
Let's say like if we have the number of cluster, then the speed will be increasing, right?
Number of nodes, number of systems.
Yeah, number of system.
Hmm.
So who
Any-
will configure that?
how many systems required? That
Yeah.
see, depending upon your incoming volume of the data, incoming data, right? What is the volume of the data, incoming data? We are just going to design the cluster. We are going to perform commissioning or decommissioning it, whether you want to add that or we need to remove that. So depends upon the incoming data, how much data is depending upon that cluster. You will anyhow you are going to maintain a bigger cluster capacity, right? So that it can accommodate huge volumes of data and you can achieve more speed. If more number of slaves only, you can achieve more speed. Today you are expecting a very high speed. That's the reason you are going for this big data Hadoop or this Spark, right? Where more number of systems running parallelly, then you can achieve more speed. So depending upon that, we'll be configuring this.
Okay.
And just we are only going to specify the block size. All this we are not going to take care. Everything, if we just give the block size, automatically it will divide into blocks. It will store across multiple systems. And whenever you trigger that, your task is going to be executed. But here I got a query. I got 2 queries here. In case 1, if you go to this case 1, right? Number of blocks 4, number of slaves also 4. 4 blocks, 4 slaves. As these are machines, 4 machines are running parallelly, executing 4 tasks, T1 task to S1, T2 task to S2, T3, and T4. T1 is for executing B1, T2 is for executing B2, T3 by B3, T4 by B4. So who should execute? 4 systems are executing. 4 systems executing 4 tasks parallelly. Suddenly the system is down. As they are machines, if any system goes down, I said each system has got 10 lakh, 10 lakh, 10 lakh, 10 lakh records. Each system storing a 10 lakh, 10 lakh records. Suddenly one system is going down. 10 lakh records are lost. 10 lakh records are lost. If it is sensitive data, like banking data, huge loss. 10 lakh records means huge loss. If it is insensitive, like Facebook data or social media data, it's okay. But if it is sensitive data, right, huge loss for that. How Hadoop is going to overcome this kind of issue, right? So if multiple systems running parallelly executing multiple tasks, if suddenly any system goes down, then there is 2 things you can observe. 2 things you can observe. One is data loss, 10 lakh records are lost. Second thing is this task fails. 2 things you can observe. One is this data loss. Here, just observe, right? Here, 4 tasks are executed by the 4 systems. Suddenly, if any system goes down, 2 things you can observe. One is the data loss, 10 lakh records are lost, and T2 task is failed. How Hadoop is able to overcome this kind of thing means? Yes. Hadoop is going to handle it. We have got a concept called replication and fault tolerance. Fault tolerance, replication and fault tolerance. Replication and fault tolerance. By using this, you can just handle that. Replication is nothing but a duplication. We can duplicate the blocks. Even one block is lost, still other block will be available in other systems, right? So Hadoop has got a replication and fault tolerance. It has got powerful fault tolerance model. Means if multiple tasks running, if any system goes down, immediately the task will be assigned to the any of the other slave, and so that the job won't be failed. See here, if I said if the task is failed means job will be failed. If the task is failed means job is failed.
Sir, if all the slave is occupied, then it will have the ability to auto scale one slave and assign the task.
Auto scaling feature available.
Oh,
But okay, but here okay, if you have got fixed size cluster, if you are maintaining, a fixed size cluster, so
yeah. So if we have all the slave is occupied, then it would be not able to assign the task, right? So it has to perform the auto scaling something.
so here okay, that's what anyhow here there are 2 types, right? So if you are maintaining a very big cluster with many number of slaves, it doesn't mean that in a single system you can store multiple blocks. If only 2 systems, S1 and S2, only S1 and S2, but 10 blocks are there, 5 blocks here, 5 blocks here. If 20 blocks are there, 10 blocks in this, 10 blocks in this. What is the drawback you observe if multiple blocks are stored? Here 9 tasks will be in the waiting state. Here 9 tasks will be in the waiting state. If 100 blocks also can be stored in a system 1, 100 blocks also can be stored in system 2. But if more number of slaves, all the tasks will be executed parallelly. Okay, more on this I'll be discussing in the architectural part. Storage architecture, processing architecture I'm supposed to discuss. Storage architectural components and processing architectural components. So this is what I have discussed till now. I'll forward this entire thing. Hadoop is for batch processing, not for online. Drawbacks with the databases, client server architecture, single master and master responsibilities, slave node responsibility, Hadoop advantages, Hadoop proven in the market, storage point of view, processing point of view, why databases like Oracle won't support unlimited storage, right? And in how exactly data stored and processed in Hadoop, and design principles with respect to HDFS blocks, configuring block size, which is advantages having bigger default block size as smaller one, right? Okay, fine.
Sir, for Python, we have to join the other batch.
So it says everything in the weekend means it will be time taking process. So I'm going to provide, I will only be taking the Python sessions. So you'll be given knowledge on this. 1 second, where is it? So Python Core Advanced, both I'll be around for Python Core Advanced, around 50 sessions I'll be discussing on this Python, because you should be good, you should have good knowledge on this Python, because total implementation in Python. So Monday to Friday, you will be having sessions for it. Either morning sessions will be there, evening sessions will be there. 6 a.m. or 9 p.m. will be available, right? You can join any of this. It means multiple sessions, 6 a.m., 9 p.m. So, but this Hadoop remaining things I'll be discussing around 16 weekends it goes. around 4 months. Even Power BI is going to be covered for visualization. So everything goes in the Linux environment, right? So I'll be briefing you about the Linux commands, means how much knowledge required about the Linux, that much knowledge I'll be providing this database. And also from the DURGASOFT side, it is offering a 2 months free Oracle training, right? Who joins this? Yes, Madhu Patil, right? Any real-time project will be covered. Yes, I'll be covering one at the end. I'll be discussing a entire project flow. How can we practice this Spark? Locally, we need to install Spark. Our cluster will be. See, yes, Madhu Patil, right? Yes. How you can execute this Spark code, anything. See, I'll be showing you different environments where you can execute this Hadoop and Spark code. I'll be providing you an image, VMware virtual machine image I'll be providing you. In that you can execute. In Jupyter notebooks, you can execute. In Databricks, you can execute. How we can get a free Databricks account, how we can get a free Databricks account where you can work freely in Databricks. And in Jupyter Notebook, how you can execute in this Spark code and run this. And also in the VMware virtual machine image, I'm going to provide you. You are going to download it. And I'll discuss about the software. I'll take a separate session for the software discussion. Yes. So yes. Tomorrow, yes. 1 second. Tomorrow also you can attend the session, but tomorrow at 4 p.m. you can attend the session. 4 p.m. using the same link. Using the same link, you can go. Tomorrow at 4 p.m. we'll see more discussion on this. Right? Any other queries you have got, anyone, right?
Sir, for PySpark, we can use the Scala as well, right?
Hmm?
For PySpark,
Hmm.
we can use the Scala as well, right? For the Spark module to implement, we can use the Scala language as well, right?
Spark can be implemented using Python, mostly used. Spark can be implemented using Scala. Spark has got multi-language support, multiple languages it is supporting, right? These two are never used, never preferred. Only these first two are preferred. Spark by default built using Scala language. Previously in the initial days in 2016, 17, 18, 19, right? Scala is mostly preferred, but these days Python is mostly preferred. Spark with Python implementation, because Python has got many modules towards, especially for analytics. Is providing many models. That's why today Spark with Python it is used a lot. Even Spark with Scala also used. I'm saying it is not used. And Spark with Scala also can be. Means the Spark, what are the Spark related functionalities? Everything will be same. Only that language programming is going to differ in Python, Scala, and Java. Or if you define how you define a variable in Python, how you define in Java, or if you define in Scala, right? That is the corrections how you define, functions how you define, that is going to differ, right? So here totally you are going to get the knowledge on this Python core and advanced. Total knowledge on this PySpark. You can just go to the course content and Hadoop also, and Power BI, Linux, and MySQL. So all this you are going to get. So yes, 16 weekends, and apart 16 weekends excluding Python. Python you need to attend morning, any of my morning or evening batches. Many multiple batches will be there. Uh, that will be for around 40 to 50 sessions. 50 sessions will be discussed on that. Yes. So tomorrow at 4 o'clock using the same link you can attend. 4 p.m. tomorrow, same link. Yes, to see more discussion. So get enrolled. Also those who didn't enroll, right, try to get enrolled. So you can see a message given by the online team, a very big message given, their contact details, the payment details, and this course
Uh,
content.
how do I access the recording of this session? I got temporarily disconnected.
They'll forward you to your mail with whatever mail you have joined this meeting. To that mail, they'll be forwarding the recording. After 1 hour, you will be getting it. Initially, once you get enrolled, you will be getting to your Google Drive. See, if you have got enrolled, you will be getting the video to your Google Drive with whatever Gmail you have.
Sir, is there
That,
any offer going on which is offering 70% discount on the course fee?
what is that?
Sir, is there any current offer going on? Is DurgaSoft running any offer currently on the courses?
See, already it is an offer batch because
There's
of
70% of Ugadi's special offer, 70% off is mentioned on the channel.
yes. 70% after that only you are getting this offer because only for one course, only for Python it is 10,000 this charge, right? And
20,000 is after the discount or
after discount only means whatever the fees given, it is very reasonable price it is given. Means we have discussed about 5 technologies we are discussing, right?
and so whatever things you're going to teach, will it make me industry ready with 3 to 4 years of experience or 5 years of experience?
A typically 4+ years of experience person, how much knowledge he is going to gain, you are going to get that much of it.
And what kind of roles or job profiles will I be able to target after completing this training?
See, you can go as a data engineer, you can go as a Spark developer, and even if you are, I said you will be getting total knowledge as a Python, even you can go as a Python developer, right?
So
So
if I apply as a data engineer, will I be expected to work on like to have a knowledge of Azure data engineering also?
see, one thing, right? Any data engineering course, Spark is the main execution weapon. Spark is the main tool. Everywhere the execution, Spark execution, PySpark execution is going to see. So you are going to get the in brief knowledge about this PySpark. In this means totally you can just check the course content, right? How much brief we are going on this PySpark. In the data, in this Azure data engineering courses, they'll be discussed more on this Azure related things. They'll be giving some overview about this Spark, but here in this total full knowledge on this PySpark we are going to get. Yes.
But in future, if I have to grow in my career, I will be expected to learn Azure data engineering, AWS data engineering, and GCP data engineering also, or
Uh,
it's not required.
so as if you are in the software field, you should be a learner. Should always be a learner. So initially, right? Initially, if you go back to 2012, right? Only in Hadoop, there was a component called MapReduce. If you got the knowledge on MapReduce, it was a hot cake in the market. Later, many components like Apache Pegas come. Again, it was a hot cake. Later, totally after Hadoop Spark. In this way, you should always be a learner. Means with the basic knowledge of this data engineering, you will be keep on updating, right? So in this not like a total advanced level you are going to see. You can see the course content of the PySpark. All these functionalities I'm going to cover with many working examples. I too handle data Azure data engineering courses, AD, Azure Data Factory, Azure Databricks, Azure Synapse Analytics
But there are
batches.
so many things, don't know what to learn and what to avoid.
See, one thing, you just check PySpark jobs. You just click PySpark jobs. Lot of jobs for PySpark. Today, PySpark is the hot cake in the market. If you go for this, any course, right? Any cloud you take, anything you take, PySpark is the, if you go for data engineering side, PySpark is the main execution tool that is used. That even if you go for interview, they ask questions on this. So that's why in this course, right, mainly Spark. 70% of my total time I'll be spending on this Spark. Even if you go tomorrow, if you go for interview, also they'll ask many queries on this Spark, some components on this Hadoop. So PySpark is the main thing.
That you are working for any company?
So I'm totally into training now.
Oh,
Previously, I used to work on this big data. Yes.
okay.
Okay. So tomorrow also people can attend. So you can just check this PySpark jobs, right? Today, even as a PySpark developer, you can demand the salary, right? 1.5 times more than the other technologies. Even 100% hike you can ask for this, especially like technologies like PySpark. There are people who has got good skills, good knowledge, command on this PySpark, right? You can just demand for it. This is a kind of technology which demands that. The same way, they'll be expecting the skills from your side. So each and everything I'm going to discuss from this functionalities of PySpark. Fine. So these are the things I'll be covering as it. All the prerequisites, whatever required will be. Only thing is, you should be interacting in the sessions. You should be doing the practicals. You should complete the practicals the day itself. Yes. So you'll be getting in brief, in-depth Python knowledge also in this.
And so for setting up the lab locally on the machine, what should be the minimum configuration of the laptop for installing or setting up the lab? How much minimum RAM
See,
and is required?
one thing, 8 GB required. 8 GB minimum required. If you've got 16 GB, it is much more better. If you are using older systems, 4 GB, I'll be providing different softwares. If you've got old configurations, I'll make you run the software in that even less GB of RAM. Only the RAM is required. If you've got good RAM, it's fine. If you can extend your RAMs also, 8 GB will be the minimum good size.
And so internal storage, how much
Uh,
storage is
no,
free storage
no,
space is required?
no. Instead of storage, right, we'll be taking some examples on those. Only thing is RAM is required because Spark deals with in-memory computation, right? Spark is a in-memory computation systems, totally memory level, RAM level computation. That's why I'm dealing with RAM only. Disk level, no.
You
So
mentioned something related to a virtual machine that you will be sharing.
yes,
So
yes. The
for installing a virtual machine, there should be 40 to 60 GB free space in the hard disk. Is that correct?
hard disk, the minimum like a 20 to 30 GB should be free. 20 GB minimum.
Okay.
20 GB should be free in your hard disk. 20 GB of space should be free in your hard disk minimum. And
Do we need GPU also? An external GPU?
see, nothing. All this not required. Only any system, in any system it can run. Not a worry about it. Only the RAM is 8 GB. Even if you got 4 GB, I'll say how to run it. 8 GB will be the better thing, and 20 GB of space is required. I'll just provide some 7 GB software on your Google Drive. You are supposed to download it and you need to install it. I'll be showing you those things. Even in Cloudera distributions also, you can download Cloudera distribution also, right? It will be of 30 to 40 GB, it will be there. But instead of that, it will take a lot of time with 8 GB, 16 GB also, it runs slow. I'm creating that, and I'm going to create a distribution, and I'm providing you where you can run with a minimal RAM size with minimum hardware configurations, right? Where we can for lab purpose for executing and checking it. Later, I'll show you how to run this Spark code in the Jupyter notebooks. Later, I'll show you how to run in Databricks notebooks. I'll be showing you different environments where you can get command on this entire Spark code. Okay, fine. So tomorrow you can attend the session at 4 p.m. using the same link to see more discussion that will continuing from where we have stopped. Fault tolerance and replications of Hadoop, right? Yes. Thank you all for your time. Thank you. Meet you tomorrow at 4 o'clock.